We've always had a fascination with the night sky for thousands of years, and while ancient civilizations have constructed maps on the movement of stars, it was only 18 years ago when we observed that the universe expansion rate was accelerating. The most common explanation for this phenomenon is dark energy, which is thought to allow the universe to expand without the hindrance of gravity. In fact, dark energy is a vital component in our current understanding of the universe. However, we don't have any direct observations of dark energy itself, much less actual verification that dark energy exists. Maybe we should consider an alternate theory. Maybe one that features things I have already confirmed to exist, like antimatter. But first things first, what is antimatter and why does it matter? Matter is made of atoms, which are made of subatomic particles, electrons, protons, and neutrons. Antimatter is also made of atoms, which are made of subatomic particles, positrons, antiprotons, and antineutrons. Matter's subatomic particles are electrically opposed with antimatter subatomic particles. But what if there's more than that? What if antimatter and matter were gravitationally opposed? What if antimatter and matter rarely make contact because they're gravitationally repelling each other? It would explain a number of mysteries, like why haven't we been annihilated yet? Or why the universe expansion rate is accelerating. Number one, why haven't we been annihilated yet? The Big Bang Theory for the beginning of the universe states that equal amounts of matter and antimatter were created 13.8 billion years ago. The thing is, when matter and antimatter make contact, they annihilate each other. It's kind of like how 1 plus negative 1 equals 0, 1 being matter and negative 1 being antimatter. They cancel each other out. So why weren't we annihilated 13.8 billion years ago? Well, if antimatter and matter were gravitationally repulsed, they would have never made contact in the first place. Number 2. Why the universe expansion rate is accelerating. Gravity. It's attractive, in that gravity pulls matter closer to each other. In order to escape this gravitational pull, matter must move fast enough to escape gravity's attractiveness. Take a rocket, for example. In order to be launched into space, the rocket must be launched at a fast enough velocity to escape the pull of Earth's gravity. But if the rocket doesn't move fast enough, then the rocket will slow down to a stop before being pulled down to Earth. All the matter in the universe has gravity. The combined gravitational force of all the matter in the universe should slow down the universe expansion rate. So why was it that 18 years ago that astronomers observed that the universe rate of expansion was accelerating? Well, if the gravitational force of matter is cancelled out by the negative gravitational force of antimatter, then the universe ultimately has zero net gravity force. In other words, the universe has nothing to hold it back from expanding, not even gravity. The way antimatter is affected by gravity could solve several of physics' biggest mysteries. It explains why all the visible matter we can see wasn't annihilated in the Big Bang, and it explains why the universal expansion rate is accelerating. In other words, antimatter might matter,